exercise 10 asks that we solve the following inequality, that's 2n is greater than 20, or 2 times n is greater than 20, and then graph the solution. So just as a reminder, whenever we're solving for an inequality, because here it wants us to solve it and put the solution into here, this little box, whenever we're solving an inequality, what we're doing is we're solving for the values of n, in this case, or any variable, that are going to give us true statements for the inequality. So I've written that here the solution of an inequality is the values of the variable that make the inequality true. Because as we've talked, n here in this case can represent any number. So n could be anything from negative infinity to positive infinity. However, there are only certain numbers of n that we can substitute into n that are going to give us a true statement. For example, 2n greater than 20, if I decided to plug in, let's say, 30, that'd be 2 times 30 is 60, and 60 is indeed greater than 20. That is a true statement. But if I decided to plug in 1, 2 times 1 is 2, which is not greater than 20. So just because n can be any number doesn't mean that any number is going to give us a true statement. So how do we determine the solution of 2n is greater than 20? Well, that means that we're going to need to get the n by itself, and getting the n by itself tells us what n can equal, what values n can be, so that we get a true statement every time. And n, in this case, is attached to this 2, and this is a multiplication operation, because 2n, another way of saying 2n is 2 times n, is greater than 20. We want to get rid of that 2, and because this is a multiplication problem, we're going to need to put a 2 underneath it by dividing both sides by 2. Remember that any number divided by itself or any number over itself is always going to cancel out to equal 1. And so that's going to be n on the left side. And then over here on the right side, 20, we're also going to divide by 2, because whatever we do to the left, we have to do to the right. 20 divided by 2 is 10. And then because this is a positive number, we don't have to flip the sign. And so it's going to be n is greater than 10. That's the solution that we're going to plug into our little box here. And then, but that's not everything we got to do. We're also being asked to graph the solution. So if we need to graph the solution, we need to graph n is greater than 10. So in order to graph this, you need to ask yourself, do I need to use an open circle or a closed circle? Can n equal 10? Well, according to this inequality, n is only greater than 10, not greater than or equal to. And so if n is greater than 10, that means that 10 itself is not a solution. And when a number is not a solution, we use a open circle. So it's going to be one of my two options here. To determine whether my arrow is going to be moving to the right or to the left, I need to ask myself, n is greater than 10, so does that mean that the numbers greater than 10, are they going to be going to the right or to the left? And numbers greater than 10 are going to be going to the right. Anytime the variable is going to be a greater than, then it's always going to go to the right. Anytime the variable is less than the number, it's always going to go to the left. So hopefully exercise 10 gives you an idea of how to do exercises 11, 12, and so on. So for exercise 11, I'm not going to work it out all the way for you. We're doing the same kind of thing. We're solving this inequality, means to get the variable c by itself. And then we're also going to graph the solution of the inequality. So I'm going to do just a similar problem. So in my example, for number 11, I've got c over 6, which is the same thing as c divided by 6, is less than or equal to negative 3. Well, if this is c divided by 6, that means that the number that we need to get rid of, that 6, is on the bottom of the c, on the bottom of this fraction. So we need to determine a way of getting a 6 to the top of this fraction of c over 6 in order to have those 6's cancel out, because any number over itself equals 1. And because this is a division operation, that's also my hint that I'm going to need to multiply in order to figure this out. So I can multiply by the same number, 6, and multiplying by 6 is 6 over 1. And if we cross-simplify this, we get that 6 and 6 can cancel out to equal 1 and 1, because 6 and 6 can both be divided by itself. And 1 times c is just c, and 1 times 1 is 1. And then c over 1 is just c, because anything divided by 1 is simply that same number. And so I just got the c by itself. Technically, there is a 1 next to the c, but we don't show it. And I did that by multiplying my left side by that positive 6, so I'm also going to multiply the right side by a positive 6. And because it's a positive, I'm not going to flip the sign, so I'm going to keep that sign the same. Negative 3 times 6, that's going to be negative 18. And so I just solved out for the values of c. c is all values that are less than or equal to negative 18, and that means all values less than or equal to negative 18 give us true statements. All values less than or equal to. What's another way of saying less than or equal to? They could say all values no more than negative 18 give us true statements. And now if I wanted to graph this solution out, well, then I would need to find negative 18 on my graph. And can c give equal negative 18? Is negative 18 a solution to this inequality? Well, we said that c is less than or equal to negative 18, so yes, it can be. So I would use a closed circle. And c is less than negative 18, and if it's less than negative 18, it's going to be going to the left. And so that's just an example, but you're going to need to solve exercise 11 on your own using the same kind of techniques we talked about in order to solve out this exercise. Number 12, exercise number 12, is similar to problem number 10 because it starts off as a multiplication. This is 2 and 2/10 times m is less than 11. Remember, with all these, I want to get the numbers that are attached to the variable. I want to get them over themselves. And so if this 2.2 or this 2 and 2/10 is on the top, then I can go ahead and divide by 2.2 in order to put that number over itself, cancel it out to equal 1, and then I'll get m on the left side. I divided by a positive number, so I'm not going to flip the sign. And then now you need to determine what 11 divided by 2 and 2/10 is. Let me give you an example. What if I did 33 divided by 1.1? Well, then I would do first number on the inside, second number on the outside, bottom number on the outside. This is not a whole number on the outside, so I'm going to move the decimal over one place to turn it into a whole number. So that's going to turn into an 11. And in this 33, if this was $33, we would have the decimal to the right of it. And so this decimal we're also going to move over one time, which turns it into a 330. And 11 goes into 330. Well, 11 goes into 33 three times. And then that's going to give me a remainder of 0. You can drop down this 0, but that's just going to be another 0. So let's actually bring it up and turn that 3 into a 30. So 11 goes into 330 30 times, which means that 33 divided by 1 and 1/10 is 30. But that was just an example. You'll have to do the same thing to the 11 divided by 2.2 using the same kind of division techniques, and then graph the solution. Exercise 13, also the same kind of problem as the last few that we've been doing. The only thing is that this looks a little different than what we're used to. We actually have the division sign here, but that's no different. X divided by a number, let's say x divided by 5, is no different than x over 5. That's still x divided by 5. And then if my example was negative 2 is greater than x divided by 5, what I would do is you could either visually turn it into what we just talked about. We could turn it into the fraction form where instead of x divided by 5, we turn it into x over 5. Or you could just recognize that because this is division, or this is x over 5, I'm going to need to multiply by 5 on both sides in order to solve out this inequality, this example inequality. And that divided by 5 and multiplied by 5 will cancel out to leave you just the x, just the same way it would over here. And then over on the left side, I would just multiply that out to find negative 10 as my new number here. I multiply by a positive number, so I'm not going to change the sign. And then the x is going to stay by itself. And so I would get that x is less than negative 10. So I might have done that kind of quickly. Let me go ahead and just do another example just to be safe in case it didn't make sense the first time. So let's say I had negative 5 is less than x divided by 3. Well, that x divided by 3 can be written in a different fashion. We can say negative 5 is less than x over 3, and it's still the same thing. That's still x divided by 3, but just now in a different kind of perspective. The 3 is on the bottom of the x, and I want to get rid of that 3 and turn it into a 1. I want to cancel it out. Because the 3 is on the bottom, to get a 3 on the top, I'm going to need to multiply a 3 over 1, which is just multiplying by 3, to both sides of this inequality. X times 3 equals 3x. 3 times 1 is 3. And then 3x divided by 3 is 1x because those 3's cancel each other out. And then 1x is equal to simply x. I multiply both sides by a positive number, so I'm just going to go ahead and drop this straight down. I'm not going to need to flip the sign. And then negative 5 times the 3 that we multiplied both sides by is going to give me a negative 15. And so I get my solution that x is greater than negative 15 in this example. So you're going to use that same kind of technique to determine the answer for exercise 13. And then if I were to graph this out, x is greater than negative 15. Just as a review for graphing, that means that x cannot equal negative 15, so you would be using an open circle. And if x is greater than, anytime x is greater than, the variable is greater than the number, you're going to be going to the right because numbers get greater, you could say, or they get larger as we go to the right on a number line.